Hi everyone, today we're going to be solving Edexcel GCSE Chemistry Unit 4CHO. Today we're solving paper 1CR, June 2017. In this particular video, we're going to be solving the entire question paper. Bromine is an element in group 7 of the periodic table. Which of these is the formula for the molecule of bromine? So the bromine molecule will have the symbol Br, and since it is a diatomic molecule, so it's going to have Br2. So D will be the correct answer. A small amount of liquid bromine is placed in a gas jar containing air. The jar is then sealed. After 2 minutes, a brown gas is seen just above the surface of the liquid. After 2 hours, the whole gas jar is full of brown gas. Which of these is the process that causes the brown gas to fill the gas jar? So the process is asking about the brown gas filling the gas jar. That will be diffusion, because we know diffusion is the movement from a region of low concentration, from a region of high concentration to a region of low concentration. Explain using the particle theory the observation seen in the gas jar. So we will explain it like this. The bromine liquid first evaporates, and then the bromine liquid, some particles escape from the liquid. Those particles that has escaped from the liquid by evaporation, they fill the gas jar because the particles move randomly and freely in all directions. This apparatus is used to demonstrate the movement of ammonia gas and hydrogen chloride gas. In one side, we have cotton wool that is soaked in concentrated ammonia solution. On the other side, we have cotton wool that is soaked in concentrated hydrochloric acid solution. The gas is given off by the solution at each of the end of the tube. When the gases meet, they form white solid, which letter shows the position where the white solid forms. We know that ammonia is NH3, and NH3 has a molecular mass of 17, and hydrochloric acid is HCl, which has a molecular mass of 36.5. So the one that has heavier molecular mass will move slowly. That means HCl gets a lesser chance to move, whereas ammonia gets a greater chance to move. So definitely the answer will be C. Iron is a metal that has many uses. One problem with iron is that it can rust when exposed to air. Name the two substances that must be present in the air for iron to rust. In order for iron to rust, there must be at least water and oxygen both present together. These are 4 methods of preventing iron from rusting: painting, oiling, galvanizing, coating in plastic. The table lists 3 items made from iron. Complete the table by giving the best method of preventing each of the item from rusting. So a bicycle chain, we can oil it. A bridge, we can paint it. A car body, we can also paint it and galvanize it. Which of this metal is used to galvanize iron? So we will use zinc to galvanize iron because zinc is more reactive than iron. The box shows some method that can be used to separate mixtures. Now complete the table by giving the best method for each separation. To obtain a sand from a mixture of sand and water, definitely this process will use filtration. To separate crude oil into its components. So crude oil has, it has different fractions which has different boiling point. So we can use fractional distillation. To obtain pure water from seawater. So to get pure water from seawater, we can do normal distillation. So we can say simple distillation. To obtain ethanol from a mixture of ethanol and water. Ethanol has a boiling point of 78, water has a boiling point of 100, so we can use fractional distillation. When a mixture of ethanol and water is separated, 2 colorless liquid A and B are. Liquid A is ethanol containing a small amount of water, and liquid B is pure water. Describe a chemical test to show the liquid A contains water. For testing for water, a chemical test that can be used is either anhydrous copper 2 sulfate or anhydrous cobalt 2 chloride paper. Now anhydrous copper 2 sulfate has a color of white, which turns blue in addition to water, and cobalt chloride paper has a color of blue and then it turns pink when water is added. Describe a physical test to show that the liquid B is pure water. The physical test for determining pure water is either its boiling point, which is 100 degrees Celsius, or we can measure its freezing point, which is 0 degrees Celsius. The periodic table consists of elements arranged in order of increasing atomic number. What is meant by the term atomic number? Atomic number represents the number of protons in an atom, so B will be the correct answer. Elements in the same group of periodic table have similar chemical properties. This is because their atoms have the same number of So it is the outermost shell electron that determines the chemical reactivity of an element. So if the outer electrons are similar, then the chemical properties will also be similar. The elements in the period of periodic table shows a change in properties across the period from left to right. The table gives information about some elements in period 2. You can see melting point, structure, acid-base character of the oxide. Complete the table by writing one of the following words in each blank space. High or low boiling point for melting point, high or low for melting point, giant or molecular for structure, acid or basic for acid-base character of the oxide. So when it comes to melting point, for the carbon, we know the melting point is going to be very high. Nitrogen has a very low boiling point because it turns low melting point because it turns gas into at room temperature. And for fluorine, definitely is going to be low because it's also a gas. Now, in understanding for lithium, the structure is going to be giant because it's a metal. Metals have giant structures. For carbon also, it's going to be a giant structure because it's a giant covalent structure. But for lithium, it's a giant ionic, giant metallic structure. For nitrogen, it's going to be molecular because they form small molecules into. For lithium, the acid-base character will be the base character. So basic. Lithium oxide is basic, all right, where carbon dioxide is actually acidic. Nitrogen dioxides are also acidic. Fluorine oxides definitely should be acidic because metals from basic oxides and non-metals from acidic oxides. A student uses this apparatus to investigate the rate of reaction between an excess of magnesium and two different dilute acids X and Y. So the student uses, we can see a conical flask which is connected with a delivery system, and we can see collection over water is done using a inverted measuring cylinder. We have water in a trough. This is the method given to the student. Place 0.5 gram of magnesium driven into the conical flask. Use a measuring cylinder to add 50 cm3 dilute acid X and then replace the bung. Record the total volume of gas collected every 20 seconds for 2 minutes. Repeat the method using 50 cm3 of dilute acid instead of dilute acid X. So we can use dilute acid Y instead of dilute acid X after that. In each experiment, keep the temperature the same and the magnesium in excess. The student decides to use a burette rather than a measuring cylinder to add the acid into the conical flask. Using a burette would be an improvement only if another change is made to the method. State the other change needed to the method. Because we need to close the rubber bung, so we need to add the acid before adding the magnesium. State the advantage of using a burette. A burette has a better resolution than a measuring cylinder, so it's more accurate. Guys, this particular part of the reading is not needed. It's just given you for the understanding that a burette will be almost 10 times more accurate than that of a measuring cylinder. The table shows the student's results. So time in seconds is given. Total volume collected in that particular time. For acid X is 21 and for acid Y it's 48. Plot the results for each acid on the grid. Draw a curve of best fit for each set points. Explain how the curves show which acid has the greater concentration. Y has the greater concentration because the curve for acid Y has a steeper slope showing that the reaction is faster and it produces a larger volume of gas in the same amount of time. Use the graph to find the total volume of gas collected at 70S for this acid X. So we need to find the total volume of gas collected for acid X at 70 seconds. We also need to show this particular method that we have used to obtain it from the graph. So the gas collected is 17 cm cube at 70 seconds. The average mean rate of the reaction for acid Y can be calculated using this expression. Average rate is equals to total volume of gas collected divided by the time needed to collect that gas. Calculate the average rate in cm cube per second for the first 30 seconds for acid Y. For acid Y, for the first 30 seconds, the volume of gas collected is 17 cm cube. So we're going to divide the 17 with 30 to get 0.57 cm cube per second as an answer. Copper and iron are metals. They have the typical properties of metals, including high melting point and high and good electrical conductivity. Draw a label diagram to show the arrangement of the particles involved in the bonding within a metal. Guys, on the side, we must show that our circle represents a cation and our dot represents an electron. It's better to write delocalized electron. Explain why metals have good electrical conductivity. Metals have delocalized electrons which are able to flow within the metal structure when an electric field is applied. Suggest why some metals have high melting points. Some metals have very strong electrostatic force of attraction between the positive metal ion and the delocalized electrons. So a large amount of heat energy is needed to overcome that attractive forces in order to melt that particular metal. Copper and iron both form compounds containing ions with 3 plus charge. Sodium hydroxide is used to distinguish between solution containing Cu2 plus and Fe2 plus ions. What would be observed when aqueous sodium hydroxide is added separately to each solution? When we add sodium hydroxide to copper 2 plus ion, we are going to see a blue precipitate. And when we are going to add sodium hydroxide with Fe2 plus ion, we will see a green precipitate. Copper can be found naturally as a pure metal. Iron is found only in compounds and has to be extracted by chemical reactions. Suggest why copper can be found as a pure metal. Copper is very unreactive, and since it is very low in the reactivity series, that's why it does not react with other metal and thereby can be found as a pure metal. The most common method of extracting iron is by the reduction of iron trioxide in a blast furnace. The diagram shows a blast furnace. You can see the waste gases escaping, raw materials are loaded, and as this lever is going to go down, the raw materials will fall into the pit. Hot air is pumped from two sides, molten slag being less dense float at the top and molten iron being more dense sink at the bottom. Write a chemical equation to show how carbon monoxide forms in the blast furnace. In order to find carbon monoxide in the blast furnace, CO2 is reacted with more carbon to produce carbon monoxide. The equation for the reaction between iron 3 oxide and carbon monoxide is given below. Fe2O3 reacting with carbon monoxide produces iron and carbon dioxide. Explain which element is reduced in this reaction. You can see in this reaction iron is being reduced because it loses oxygen. Describe how molten slag forms in the blast furnace. In the blast furnace is loaded with calcium carbonate, which decomposes to form calcium oxide. The calcium oxide then reacts with the silicon dioxide, which then form slag. The diagram shows how a student attempts to prepare some hydrogen gas. Dilute sulfuric acid is added to silver and the hydrogen gas will be collected. Collection over water. State why no hydrogen is produced. Silver is very unreactive, so silver does not react with dilute sulfuric acid. Which of these pairs of chemicals could be used to safely prepare hydrogen? So first option, copper and dilute sulfuric acid. Copper is below hydrogen in the reactivity series, so cannot be used. Gold and dilute hydrochloric acid, same issue. Gold is below hydrogen in the reactivity series, so gold cannot be used for displacing hydrogen ions. Potassium and hydrochloric acid, dilute hydrochloric acid. The problem with potassium is that potassium is too reactive. So if we were to do it in the laboratory, it would explode. The last option, zinc and sulfuric acid. Dilute sulfuric acid should be the best option because zinc is neither too reactive, neither, very less reactive. So it's like, moderately reactive, that it can react with the sulfuric acid to produce hydrogen. In an experiment, the student then successfully prepares some hydrogen and measures the volume of hydrogen collected. She does the same experiment 4 times. In 4 times, she collects these volumes of hydrogen. Explain which experiment produces an anomalous result. In all of the experiment, we're producing above 60 cm cube as a hydrogen collected, but only in experiment 3 it shows that it produces 40 cm cube as hydrogen collected. So we will say experiment 3, because the volume collected is much lower than the other 3. Calculate the average volume of hydrogen collected. So we will add 64 plus 67 plus 63 and divide it by 3. The answer will be 65. Give one reason why it is important for the student to repeat the experiment. The student wants to increase the reliability of the measurements. That's why it is important to repeat it. When iodine reacts with an excess of chlorine at minus 80 degrees Celsius, a compound forms. The percentage composition by mass of this compound is 54.4 and 45.6. Show by calculation the empirical formula is ICl3. In order to do this particular calculation, we will first divide their percentages with their relative atomic mass. So 54.4 divided by 127, 45.6 divided by 35.5. Then we will find out the answer and we will do simplest ratio. To find out the simplest ratio, we will divide the answer 0.428 with 0.428 and we will divide 1.28 with 0.428. So basically the rule is just choose the smallest number from all of the division and then divide everyone with that number. And then we get the simplest ratio, which is 1:3. So the empirical formula is ICl3. The molecular formula of this compound is I2Cl6. I2Cl6 is a yellow solid at room temperature and forms a liquid when heated. A dynamic equilibrium exists in this liquid represented by this equation I2Cl6, reversible reaction producing ICl2 plus and ICl4 minus. When a reaction is in dynamic equilibrium, the forward and the backward reaction occurs at the same time. State 2 other features of the reaction that is in dynamic equilibrium. First of all, we will say that the rate of forward reaction should be equal to the rate of the backward reaction. And the second thing that we're going to say about it is that the concentration of the reactants and the products remain constant as the reversible reaction continues in dynamic equilibrium. Suggest why liquid I2Cl6 conducts electricity but solid I2Cl6 doesn't. The liquid I2Cl6 contains the ions that can move and conduct electricity, carry charge, whereas the solid I2Cl6 does not contain any charged particles and neither they're mobile. They're not even mobile. They don't even have charged particles, so they can't carry the charge or electricity. Bromine, chlorine, and iodine are halogens in group 7 of the periodic table. The 3 halogens have similar chemical properties but different reactivities. A teacher uses this apparatus to demonstrate the difference in reactivity between these halogens. We can see the halogen vapor that is passed. We have iron wool, heat source, and unreacted vapor getting out. The teacher does each experiment in a fume cupboard. The table shows the observation for each halogen. We have bromine, we have chlorine, and we have iodine. For the bromine, the iron wool glows brightly. For the chlorine, the iron wool glows very brightly. For the iodine, the iron wool glows dimly. Suggest why the teacher uses fume cupboard. Halogens are poisonous and toxic. Their fumes are, harmful. All right. For example, chlorine can kill you very easily. Use the information in the table to explain the order of reactivity of the 3 halogens. From the table, we can see that the chlorine is the most reactive because it glows with iron wool most brightly, and iodine is the least reactive because it glows with iron wool, dimly. So bromine will be in between them. So chlorine will be most reactive, bromine, and then iodine. And the reason will be chlorine glows most brightly, whereas iodine glows least brightly or dimly. A student states that the order of reactivity cannot be found from this experiment because bromine is a liquid, chlorine is a gas, and iodine is a solid at room temperature. Evaluate the student's statement. The student's statement is incorrect because all of them, chlorine, bromine, and iodine, were used in gases. Used as gases. So the gases were used. So the physical state at room temperature are irrelevant. Bromine, chlorine, and iodine all react with hydrogen. In each reaction, a hydrogen halide is formed where X represents the halogen. Write a chemical equation for the reaction between hydrogen and bromine. So, to write a chemical equation for the reaction between hydrogen and bromine, first of all, we will consider H2 plus Br2. Why did we write H2 and Br2? Because they are both diatomic. Then, this produces HBr. Because there are two molecules of two atoms of H, so we are going to write 2HBr. Draw a dot and cross diagram to represent the molecule of HCl. Show only the outer shell electron. So we can do this particular diagram in two different ways. H and Cl, where the Cl is represented with cross, one electron is shared with the hydrogen. This is one method. The other method that we can use is we can do circles. When doing circles, only remember the dot and cross has to be shown within the overlap. So both of these diagrams are correct. Name the solution formed when hydrogen chloride dissolves in water. Well, that will be hydrochloric acid. A student uses this apparatus to find the mass of magnesium oxide that forms when a strip of magnesium ribbon is burnt in air. So we have a strip of magnesium ribbon and we're burning it air, meaning we're reacting it with oxygen. This is the student's method. Weigh an empty crucible and lead. Place a coiled strip of freshly cleaned magnesium ribbon in the crucible. Weigh the crucible, lead, and the ribbon. Hit the crucible strongly for several minutes, lifting the lead and quickly replacing it several times. Lead the crucible, lead, and contents to cool and then reweigh. Describe the appearance of the freshly cleaned magnesium ribbon and the appearance of magnesium oxide that forms. So magnesium is a metal. Metals have a shiny color. So we will see a shiny silvery color. And for magnesium oxide, we know that it's a white powder. Explain why the student lifts the lead and quickly replaces it several times during the experiment. So why he lifts the lead? He lifts the lead to allow oxygen to enter the crucible. The reason why he replaces the lead is that to minimize the loss of magnesium oxide, which can be like a smoke and it can just fly off. Calculate the mass of oxygen required to completely react with 0.6 gram of magnesium to form magnesium oxide. The equation for the reaction is magnesium reacting with oxygen to produce magnesium oxide. So first of all, we're going to find out the number of moles of magnesium. In order to find out that, we will divide the 0.6 with 24, which is the relative atomic mass of magnesium. The answer will be 0.025 mole. Then we're going to find out the number of moles of oxygen, which will be 0.025 divided by 2. And then we're going to find out the mass of the oxygen that is needed, which is going to be 0.025 divided by 2 multiplied by 32. And the answer will be 0.4 grams. The mass of magnesium oxide that forms is less than expected. This could be because some of the magnesium reacted with nitrogen to form magnesium nitrate. Write a chemical equation for the reaction between magnesium and nitrogen to form magnesium nitrate. Guys, in this one, we're going to start with the plain magnesium and react it with nitrogen N2. And then we're going to write down the product Mg3N2. Our goal will be to balance this. Since we have a N2 on the right hand side and in the left hand side we also have a N2, now we need to match the 3 magnesium, so we're going to put a 3 here. The alkanes are the homologous series of hydrocarbons. The cycloalkanes are another homologous series of hydrocarbons where the carbon atoms are arranged in a ring structure. The cyclopropane is the simplest cycloalkane. It can be represented as you can see in the diagram. The table gives the name and molecular formula of the first 3 members of each series. So you can see methane, ethane, and propane. And in cycloalkane, it starts from cyclopropane, then cyclobutane, and then cyclopentane. One of the features of homologous series is that each member has the same general formula. What is the general formula for the homologous series of alkanes? Alkanes have a general formula of CnH2n plus 2. What is the general formula for the homologous series of cycloalkanes? Use the information from cycloalkane table to help you answer the question. Okay, you can see there are 5 carbons with 10 hydrogens. That means this is CnH2n. State 2 other features of homologous series of compounds. So when we are going to answer about homologous series of compounds, we're going to say that they have similar chemical properties. They're not the same, they're just similar, Alright. Then they have a graded physical properties. For example, they have a trend in physical properties. Okay. And we can also say that they have the same functional group. We can also say that each member differs by the previous member, alright, from the previous member by a CH2. Alkanes and cycloalkanes are saturated hydrocarbons. State what is meant by the term saturated. The term saturated mainly refers to carbon-carbon contains only single bonds. Draw the displayed formula of ethane, C2H6. So when asked, we will draw the CC single bond first because it's ethane. Then the remainder bonds are going to be between carbon and hydrogen. Each carbon must have 4 bonds. The displayed formula of cyclopropane is given below. Draw a displayed formula of cyclobutane. So the understanding is similar. There will be single bonds between the carbon and each carbon will have 2 hydrogens. So each carbon has a total of 4 bonds. The reaction between cyclopropane and bromine is similar to the reaction between methane and bromine. One product of the reaction between cyclopropane and bromine is hydrogen bromide. State the condition required for this reaction to occur. If we want to react to add an halogen, such as bromine, we have to use ultraviolet light. Complete the displayed formula for the other product of this reaction. So we will draw all of them hydrogen except one of them will be replaced by bromine. A student is given a mixture of two solid ionic compound A and B. Each solid contains one cation and one anion. Compound A is insoluble in water, compound B is soluble in water. Describe how the student could separate the mixture to obtain a solid A and a solution of B. So the student can add water and stir it. Once the student add water, compound A, which is insoluble in water, so it will remain as solid, and compound B, which is soluble in water, which it will form solution, and then filter. Once the filtration is done, we will be able to obtain solid B, and the filtrate will be the solution B. The table shows the results of two tests the student does on solution B. Add sodium hydroxide, warm, bubbles of gas that turn damp red litmus paper blue. That means this must be ammonia gas. So the ion that is tested must be ammonium, must contain ammonium ion. Add silver nitrate solution, add dilute nitric acid to the white precipitate. So this one, since we are getting a white precipitate adding silver nitrate solution, must be a chloride, and white precipitate is formed and the precipitate does not dissolve. Use the information in the table to identify the cation and the anion present. So the cation must be ammonium and the anion must be chloride. Identify the gas given off in test 1. So in test 1, we have already identified that the gas given off is ammonia. The student adds dilute hydrochloric acid to solid A. A gas turns lime water milky is given off. Explain which anion is present in solid A. So solid A, we can say that it contains carbonate ion because once the acid is added, it gives off carbon dioxide gas, which is responsible for turning the lime water milky. Give a test to show the solid A contains calcium ion. To show calcium ion, we must do a flame test. And once we do the flame test, it will give us brick red color showing the presence of calcium ions. These apparatus can be used to find the volume of dilute sulfuric acid needed to neutralize 25 cm³ of aqueous sodium hydroxide. So here we have 25 cm³ of aqueous sodium hydroxide and a few drops of methyl orange added to it. Describe how to use the apparatus to find the volume of dilute sulfuric acid needed to neutralize the sodium hydroxide. Assume that the apparatus is clean and does not need rinsing. The burette is used to add the sulfuric acid to the sodium hydroxide until there is a change in color of the indicator. The initial and the final readings of the acid were taken and subtracted to calculate the volume of acid added. The acid was added dropwise when we reached near the endpoint, and the solution was swirled more vigorously near the endpoint. The whole titration was repeated several times to obtain a concordant result. The volume of dilute sulfuric acid needed can also be found by measuring the highest temperature reached when the two solutions are mixed. In a series of experiments, different volumes of dilute sulfuric acid are added separately to 25 cm³ samples of aqueous sodium hydroxide. The graph shows the highest temperature in each experiment. In each reaction, the starting temperature of the two solutions are the same. So we can see volume of acid in cm³ in the x-axis and highest temperature in degrees Celsius in the y-axis. We can see that both of the line intersect to give us the maximum temperature reached. State the starting temperature of each experiment. The starting temperature for each experiment were 20 degrees Celsius, as you can see from here. It starts from 20. Find the volume of acid required to exactly neutralize the sodium hydroxide. So to do that, we will have to extrapolate. So volume of acid needed in this case is 17.5 cm³. Find the two different volumes of acid that produce an increase in temperature of 10 degrees Celsius. So we can see at 10 cm³ we have there is an increase in temperature of 10 degrees Celsius, and at 25 cm³ we can see that there is an increase in temperature of 10 degrees Celsius. Lithium is an element in group 1 of the periodic table. Lithium is stored in oil to prevent it from coming into contact with air and water. When a piece of lithium is removed from the oil, dried and cut, the exposed surface changes from shiny to dull immediately. Because lithium is a very reactive metal, it reacts with oxygen in the air. When lithium is added to cold water in a beaker, hydrogen forms. State the test for hydrogen. To test for hydrogen, we have to use a lighted burning splint. So the burning splint will make a pop or squeaky pop sound. A few drops of phenolphthalein indicator are added to the solution in the beaker. Explain why the phenolphthalein indicator turns pink. Since the lithium reacts with water, it produces lithium hydroxide, which is highly soluble alkaline solution. The table shows some information about lithium oxide and lithium carbonate. Complete the table by giving the two missing formula. So lithium oxide will be Li with the O. Since lithium has a valency of 1, oxygen has a valency of -2, so it will be Li2O. Just remember that valency gets exchanged between them. Lithium carbonate Li2CO3. So the carbonate will be, because lithium is Li plus, so the carbonate will be CO3 2 minus. Cesium is another element in group 1 of the periodic table. The table below lists some statement about the reaction of cesium with cold water compared to the reaction of lithium with cold water. Please tick in the boxes to show the two correct statements. The reaction with cesium is more vigorous, correct, because cesium is down the group in the periodic table of group 1. That means down the group, the rate of reaction increase, the amount of reactivity increases, so it's going to be more vigorous reaction. The reaction with cesium produces a different gas. No, it still produces hydrogen gas. The reaction with cesium produces an acidic solution. No, group 1 metal all produces alkaline solution. The reaction is not endothermic, and the reaction of cesium produces different compound. Write a chemical equation for the reaction of cesium with water. When cesium reacts with water, it produces cesium hydroxide plus hydrogen. Now to balance this equation, we'll have to put a 2 here, put a 2 here, and a 2 here. Hydrobromic acid can be neutralized by adding sodium hydroxide solution. The equation for the reaction is HBr plus NaOH, NaBr plus H2O. A solution of hydrobromic acid has a concentration of 0.2 mol per dm cube. Calculate the amount in moles of HBr in 20 cm cube of the hydrobromic acid solution. So in this case, we have to calculate the number of moles. The number of moles is equals to volume into concentration. Calculate the volume of 0.1 mol per dm cube sodium hydroxide needed to exactly neutralize the hydrobromic acid. So in this case, it's very easy because they react with a 1:1 ratio. So the number of moles of sodium hydroxide must be same. Since the number of moles of sodium hydroxide is still same, so to find out the volume, number of mole is equals to volume times concentration. So if we want to find out volume, then we have to divide the number of moles with concentration. Here the number of mole is 0.04. We will divide it by concentration, which is 0.1 mol per dm cube. This will give us 0.04 dm cube, or otherwise, when multiplied with 1000, we will get 40 cm cube. In another neutralization reaction, a student uses 30 cm cube of 0.2 mol per dm cube aqueous sodium hydroxide solution. Calculate the mass of sodium hydroxide contained in this solution. To do this particular calculation, we'll have to find out the number of moles of sodium hydroxide. We will divide the 30 with 1000 and then we'll multiply it with 0.2 to get the number of moles, which will be 0.006 mole. Then the MR of sodium hydroxide is 40. We'll find that out, and then we'll find out the mass of sodium hydroxide by multiplying the number of mole with the MR. Mass of sodium hydroxide will be 0.24 gram. So guys, thank you for being until the end of the video. Guys, hope this question paper solution helps you. All right. And in the comments, let me know what is the question paper that you want me to solve. Most recent papers will be solved by me in a chronological manner, one by one. And if you have any other question paper from past that you actually want me to solve, let me know in the comments. Definitely I'll give it a try. And guys, best of luck for your exam and see you in the next video.